reflector, the dipole, and one director for 10 meter, and interleave between that 10 meter antenna, you have in front of the 10 meter reflector, you have a smaller 6 meter reflector, and very close to the 10 meter dipole, which is connected to the choke, there is the 6 meter radiating element, but it is not electrically connected. I didn't even knew that would work. So by what I understand, you always transmit on the 10 meter dipole, but when you go to 50 megahertz, it seems the 10 meter dipole is coupling on the 6 meter radiating element, and in front of that radiating element, you have a 6 meter director just behind the 10 meter director. And when I look at your design, it reminds me that, and I was trying to see how you did connect everything. It reminds me when I see, the diagram at figure number 2, where you have the model antenna structure. It reminds me of that. It's very, very similar to that antenna type I'm talking about. So my goal was probably to get that 10 and 6 meter and remove my 10 and 6 meter dipole on the TGM antenna. So that way at least I would have a little bit more gain and way better front to back on 10 meter and 6 meter, because those bands are very fun. When the conditions are there, that's very fun bands. And here in Canada, on 10 meter, we can run 20 kilohertz bandwidth. And with the Hermes light, it's so nice to chat with other local guys here. We talk at 8 kilohertz wide or 10K wide. It sounds spectacular. It's amazing how it sounds. So a lot of fun, and a lot of projects, but getting back to your design, it reminds me of that design, and I didn't even knew it was possible to do, because on my TGM antenna, the 10 meter and 6 meter radiator touch the main dipole with all the loading costs and capacitive hat. That I understand, but not having electrical connection and being able to radiate on another frequency, I found that very interesting design. And that's what I was trying to figure out on yours. Sorry for the again long explication, but you should do something about this. I'm pretty sure. I guess it would be pretty expensive, but my TGM was like $1,000. I got it at a better price, but it was kind of expensive. I think mine is like 38 pounds, so it's a little bit lighter, but it's also smaller than yours. But super interesting stuff you got there. Very, very nice. Whiskey Yankee 2 Golf. It's Victor Alpha 2 Hotel Zulu.
Okay, very good. Thank you, Claude. Well, I took precautions. If anybody wants to build it, that's a ham operator or a hobbyist, you can do that. Commercially, I already got my, let's put it this way, the attorneys already have that capability of finding out who does it and who doesn't. Commercially, I put a warning at the bottom or a note saying that it's a non-commercial thing. If they want to talk, that's different, but depending on my antenna or this particular hybrid, you're transmitting under 20 meters. So the RF is going into the 20 meters. Then you have what we call the close coupling between, let's say, B and C. Okay, and that right there is about 5.5 feet. I'm sorry, 5.5 inches. I apologize. 5.5 inches. You're right, it is kind of late. So that right there is what we call close coupling. And then then you've got reactance from the antenna. So you got an LC network now all of a sudden. And it becomes like a coupler. So it couples RF onto the parasitic element. And then from there, you have a reflector in the back. And now all of a sudden, you're 180 degrees out of phase. So now you come with a two-element Yagi. And the 6-meter director, being from AB, that's about 10.5 inches away, all of a sudden becomes another director, not necessarily a driven element now, but as a director, although it's acting quasi. In other words, it's not exact figures or numbers or length, but it's a quasi. So that's what becomes a 2 plus. And by that, I mean the 10 meter becomes a 2 plus, element, 2 element antenna plus. And that's how it's done. Now, if you look at very carefully, you'll see a red line and a little circle in that red line on the antenna configuration. Again, the 40 and 20 meter driving element drives a 6-meter driving element, which is in parallel with it. So now we got from A to B and C. So you go from 10.5 plus 5.5 inches, and then you add that up, and then you put your 6-meter director, and now all of a sudden you have a 2-element 6-meter. And naturally we can't put a 6-meter reflector, there's no space, but we can put a director, which is actually takes a shorter distance. So everything is done by closed coupling, that's what we call it.
Wow, that's the first time I should say, I saw that design. I always thought that when you have a multi-band Yagi, each driven element had to be connected together. I'm baffled by this principle that there is no loss, let's say, from the parasitic element close to the dipole, the 20-meter dipole. You said like 5 inches. I see one of your drawings now, and it's amazing that there is no loss in that area. I mean, there's no electrical connection. That amazes me. It's able to transfer the RF energy of another frequency to that main red dipole. I see that. And this is your driven element. That's exactly how the other antenna is built, the 10 and 6 meter antenna. I found the company, it's Inov Antenna. The super simple antenna is built even with the same material that you did use, square boom, and I think those isolator that you're using are hydraulic clamps, if I'm not mistaken. Well, that's what I found that was the closest looking, were hydraulic clamps, hydraulic hose clamps. But yeah, it's built very much like yours. I'm looking at it right now, that Innov antenna, and they do a very big antenna that cover many bands, but that's very nice. And I see that you have a lot of calculation and formulas, and man, there's stuff to read on your page. I will look into this for sure. Because next time I plan to have a better performing antenna than this one. And I mean, I'm very happy with this one, but yeah, an awesome deadline. I cannot say more than that. Whiskey Yankee 2 Golf. This is Victor outside 2 Hotel Zulu.
Yeah, Whiskey Yankee 2 Golf. Well, yeah, that's. I think you'll have a lot of fun in reading this. I'm implementing a high mutual coupling technique, and that's what it is. It's I'm sure you've seen, for example, antennas, right, that have no balance at all. Let's take a dipole. Put a dipole up there, just run a direct coax and bring it down right to your radio, and I guarantee you're going to have CMC, which means that the coax now is radiating like an antenna. You got that?
Yes, I do. I did my own choke using 2 pair of 12 turns of PTFE. I think it was 16 gauge on a 240-43 choke, not choke, but core. And yeah, because the choke that came in with the original antenna was performing very poorly, and I had a lot of issues with RFI in the shack here. And then I built my own, and it works very nice now. So this is what I'm using right now. It's a pair of 12 turn. I'm missing the English word, but yeah, 12 pair of enrollment. It's not the right word. Anyway. You understand what I'm trying to say, I'm pretty sure, but yes, I understand what you're explaining to me.
Okay, very good. Then you understand how that works, then. So now all of a sudden, that piece of the coax that's floating, now you put it towards the tower or a pipe, whatever you want to mount it antenna to, or the coax, and now that pipe or the structure, it becomes a vertical element. Even the coax itself is coupling RF, not by inductance, by capacitance. So now all of a sudden your capacitive coupling the RF energy onto an element that resonates in a different frequency. So now the frequency is looking at the radio, and the radio says, I'm happy because that frequency matches the frequency I'm transmitting. The radio says that, and the antenna accepts that frequency because it's tuned to that frequency. So that's what we call a high mutual coupling. Now the other part of it that most people do is what they use a direct coupling, meaning that they're going to have elements, driving elements say 20, 10, 15, and so forth, directly coupled to the coax, the center of the coax. And then all of a sudden you got on one side you have the center, the other side you have your ground. And so you isolate all the elements. The design that you see in front of you also isolates the element that drives the direct 20 and 40 and 6, but the rest of them are all parasitic. So it means that they're all acting as coupling devices. Very similar to what you do to a transformer. You have 120 volts, and if you wind 120 volts on the primary and about 10 turns, let's say, or 100 turns, and then you got 100 turns on the other opposite side, you'll still get 120 volts, because now you're electromagnetically coupling the energy from one coil to the other.
Wow. And I got even further down your page and I see all the formulas and oof. I mean, you know what you're talking about. That's for sure. Yeah. Wow. I never knew that was possible until I found that antenna design. I never saw that before, and I mean, I got licensed early 1990s, so but I've experienced a lot of things. I've made a lot of contacts with space station, near space station, international space station, meteor scatter. But I mean, I did try a lot of stuff in ham radio. I had a lot of fun, but I never saw that design, and I'm baffled. I understand, but now reading your page, there's so much going on your page. That's amazing. Wow, yeah, and I see the bandwidth resonance and bandwidth. And, that's amazing. I think I'm going to print your page and read this. Yeah, for sure. Wow, that's very interesting. I think I read somewhere scrolling to your page very quickly, but I mean, you're in the RF field for sure, right? I think I read that you are in the RF business, or did I read that right?
Yeah, that is correct, Claude.
Yeah. All right. Well, I'll try to understand all of that, and that might be a very nice project to build. That's for sure. So, and I see that you have dimensions and part supplies, and wow, that's awesome. I'm so glad that I was just about to miss you. You were leaving, clearing the frequency, and very happy to bump into you, John, tonight.
Well, the pleasure is mine. I usually, don't talk this long. I do communicate with a lot of folks, and we talk, within 5, 10, maybe 15 minutes or so, and then we're done. But this time, I think we're doing it very nicely and very comfortably. I mean, I'm having my cup of coffee right now, Claude. What you call it, say my early breakfast, I guess. And I'm not tired, so it's nice. By the way, I took my inspiration from my dad, believe it or not. He was Greek, and he taught me a lot about philosophy and so forth. which I thought when I was a young kid, I didn't even care for it. But anyway, so I took mythology and school, and that really opened my eyes. It was really fun for me. And then another individual that really motivated my career, you may say, was a gentleman called Nikola Tesla. And he was a Serbian-American scientist. And he's actually the one that made in the word, I put it even on the website, he actually made the world system. And he was not an egoist. He was not it was not a selfish individual. He actually sacrificed his life for it, and he loved it. So I studied his writings, his patents, and I came out to different conclusions, and I made some circuits out of his ideology, and he was a great scientist, an exceptional genius, one of the greatest engineers we've ever had. I don't think we'll ever even have anybody ever like him again. He actually experimented in the early 1890s and showed it to the public with stuff that people didn't even understand at the time. You know, he actually came up with breakthroughs with remote access and radio way before Guglielmo Marconi. And I do respect his Guglielmo Marconi, but Marconi actually took some ideas and applied it to his patent. But the one that really came up with radio and that kind of a technology, wireless technologies, and showed it to the public in 1890, way before anybody else did, was Nikola Tesla. So he actually used some of his circuitries, which were planar spiral inductors, and one of them, the biggest one of all, is actually the rotating magnetic field, and then the Tesla coil. I'm sure you heard of that. And so out of that, you come with what they call a coupling, XC coupling, reactance, capacitance, and reactance, inductance. And fantastic reading if you ever want to read his life story. Well, that's pretty much. I think you'll enjoy it. I believe you're an individual that you'll find it interesting. I don't know if you really want to print it, but it's up to you. You're a ham operator, and that's what it's for. I don't want it commercial. It's for individuals as a gift, that type of a deal. A lot of other individuals have done the same and applied their methodology and their experience and put it on websites, and mine is just a little corner of the world that I have. So I hope you enjoy it. Thank you so much for the contact, Claude. And I'll give it to you for the final, unless you wanna ask me a couple of more questions. By the way, real quick, the MSJ 998, I played with this. An excellent piece of equipment. I know that they went up in price, but once in a while you find it on QRZ for a used one that has barely been used for about $400 or $500. And it's an excellent piece of equipment. It's all switched LC networks for matching through processor, and then the hard switching is done by relays. And I stopped over at the company over there at one time, and I saw how they work. They're okay. They're good people, but they don't have much of what you call quality control. although as the years gone by, I think they've gotten much better. So I think you'll enjoy that remote capability that tuner has. They do make a remote tuner, and they also make a tuner that you can put on your desk or in a remote location, and still can get as good as WR, because the minute you key, that thing will tune up by itself. VA2 8Z WY2G.
Whiskey Yankee 2 Golf this Victor Alpha 2 Hotel Zulu. I would have a ton of questions still, but my eyes are getting scratchy. It's almost 3 in the morning. I should head to bed, but talking about the Tesla. For me, I mean, I know a little bit of his life, but what struck me the most is how it ended. That's terrible how it ended, and what happened with Edison and Marconi and those guys got or stole his ideas and his design, and I think he even got sued or something over patents. That's horrible what happened, and I'm amazed that you found ways to use some of his principles that were designed 100 plus years ago and apply that to antenna system, modern antenna systems. That's very amazing, and I will enjoy reading your page for sure. I put the shortcut to your QRZ page on my desktop to read back. I won't do that this morning. I'm way too tired now, but that's very nice information you got there, and I will try to understand all of it. I see math symbol a little bit more advanced than I can remember from my maths in school. It's been a while, so I will try to understand the principle of your design, and it's very nice. I was about to ask maybe quickly what antenna software simulator or software design are you using? Are you using what we call it, ANA?
MetaLab.
Okay, because I was about to say, did you have the antenna design, but I could not open your design. If it had been with more broadly available software, I would have been curious to see how you did design it.
Well, it's a professional software that we use up here for microwaves, and then apply that towards it. I believe you can use Easy, if I'm not mistaken, or Easy plus 2, or plus 2 is the plus, 2 plus I think it is called, that you can figure that one out. But naturally